Hi friends, this is Aditya and you are watching a unique YouTube channel for Cisco tutorials. In this video, we are going to discuss about CCNP 2.0 switching and the topic is UDLD. So far we have discussed all those topics that I have highlighted right there. In this video, we will discuss UDLD. And I have already created and uploaded the documents number 6 or video number 6 I should say, a dedicated documents. Objective of this video to understand and configure UDLD, or sometime also known as unidirectional link detection protocol. This is the Cisco proprietary protocol used to prevent it also used to prevent layer 2 detection while your spanning tree goes fail. So we will discuss and we will try to understand how does this work, where it used. And then second objective of this video, configure, verifying and troubleshooting UDLD. So think about spanning tree protocol. This is actually used to prevent layer 2 loop. Obviously it used, but sometime if any problem occur, your spanning tree goes fail, let me go through the example that makes sense a lot. This is the default behavior of your spanning tree protocol. Suppose right now we have 3 switch or a bridge, switch A, B and C. One of switch may going to become a root bridge and rest of 2 they will become a non-root bridge. And since this port going to create a loop, one port going to block and this port become a designated port and will be on and will forward BPDU as well out of this port. Obviously even this port going to send and receive BPDU messages. So these BPDU messages actually send and receive to aware if any topology changes occur. Suppose if this link goes down, they automatically come to know this link goes down, means now it need to be turned on port so that we can access the root bridge. So it's work fine, no matter, no problem. And you may think, yes, why we are discussing UDLD? Yeah. So let me describe this situation. Hopefully after this situation you may have a better understanding the working of UDLD. What happen if this switch sending BPDU message to switch C, right? Even switch C sending message to BPDU message to switch B, everything is fine. Somehow switch C may not able to receive BPDU from switch B, maybe cable faulty or something else, maybe some other problem is exist. So switch seem that if I am not getting BPDU message from this port, I need to turn on this port. It could be happen because of several situation. Maybe you have a faulty cable or maybe something else. So you know what, now it going to create, since this side has already on, so even this side going to on, now it may become a layer 2 loop. Cisco think about this, something could become wrong if it not going to prevent. Yes, that's why Cisco use UDLD protocol. ULD I should say UDLD protocol to prevent layer 2 loops if something went wrong with spanning tree protocol. So how does this work? Let me explain it again. How does this work? UDLD you need to enable on switches, switch B, switch C. If you like, you can also enable switch A as well as the corresponding port that participating spanning tree port, either that goes to the switches. So these are the port that also need to enable UDLD. Once you enable UDLD, they will send and receive some keep live messages. They will form neighbor adjacency. So once they're not getting any hello messages or keep live messages from the neighbor, immediately they are going to turn off their port. Means they pulled their port in error disable mode. That means even BPDU messages not going to send and receive. This is what your UDLD work. Hopefully you come to know the work of UDLD. So because spanning tree may create this loop, may create this problem if your switch not getting a message or BPDU messages from this port, means from switch B to switch C, it going to open that port so that data can be sent and received. But problem may occur, as I told you earlier. So this is Cisco proprietary protocol. You need to enable on globally as well as on interface. They form neighbor adjacency. If they not getting reply back, or I mean it's kind of keep live messages, they are going to disable immediately that port. So suppose switch B getting message, switch C getting message from switch B, it will enable the port, means port will be work, talking about UDLD right now. If switch C is not able to send that UDLD keep live messages to switch B going to turn off this port. So this is how your UDLD work and prevent layer 2 loop problem. If spanning tree goes down or spanning tree has some problem, not spanning tree, the problem from the cable or something else, then after it going to work with. So there is two mode of UDLD. By default is normal, and you can also operate this as aggressive. In aggressive, it immediately going to turn off the port. In normal mode, it going to create a unidetermined port. So we'll mark the unidetermined port that going to prompt you something goes wrong. So we'll make a sense lot if we'll go through the practical. Even I would like to show you the command that we need to understand. We need to execute the command set UDLD enable globally. In fact, we also need to execute command to particular interface, so that interface turn on UDLD feature in finding neighbor to corresponding port. So let me go ahead and turn on the devices, and we'll go through step by step of configuration. I would like to go through one more example to understand better UDLD working. So in this example, we have switch A and switch B, and as we know, while we using any guided or wired transmission media, one pair, if you're talking particular about twisted pair, so one pair used to send data, another pair used to receive data. Similarly, in optic fiber cable, one cable used to send the data and another used to receive data. In this scenario, suppose by spanning tree protocol, this port went in blocking state, and this is the designated port. So switch A, let me clear this off. Switch A sending BPDU message to switch B. In fact, switch B is sending BPDU message to switch A. If everything is fine, they will still block this port because of the spanning tree algorithm. But what happens if switch A sending BPDU received by switch B, but switch B sending BPDU is not received by switch A. Your switch A will go ahead after time expire. If we'll go ahead and turn on this port, earlier it was blocked, sending and receiving the data, but then after it will decide, since I am not able to get any BPDU message from the switch B, it means I need to turn on this port. So if it need to turn on this port, it will send frame, the data frame, maybe another switch connected like this and like this. So it's going to turn on, and then after you will mess in layer 2 loop. That's why UDLD used to prevent one-off port if they are not receiving the keep live message, kind of keep live messages. So now it's time to start my devices. Alright, now my device is up and working. In this video or in this tutorial, I'm going to use two switch 1 and switch 2 that has two cable connected from F0/1 to F0/1 and F0/2 to F0/2. And maybe this is not support GNS in packet tracer. So far we have discussed, if anyhow spanning tree failed to prevent layer 2 loop, your UDLD going to prevent that layer 2 loop, because your UDLD going to turn off one-off port. So if it turn off port, means in error disable mode, no one frame going to send on receive on that particular frame. So that's good. So now it's time to apply on CISCO Gear. So let me go ahead and bring my console window. Okay, it's booting. Meanwhile, I would like to mention one more thing. It also uses CDP to get the neighbor information or host name information. Suppose if you're looking UDLD on switch 2, it will get neighbor information from the using CDP, that is switch 1, but it also working with device serial number. Since host name can be same, you can also use switch 1 on this switch, in fact switch 1 on this switch. So host may be same, but serial number every time unique. So your UDLD also use the serial number of your device, in fact the neighbor device. Actually they also send and receive these information, port ID and some other information, while they form neighbor adjacency, or I should say UDLD neighbor adjacency. So that's good. There we go. Switch 1 and switch 2. First execute the command and verify on which switch we working or what model number of the switch. So right now working on switch 2960, and then this is the model, sorry, iOS version of this switch 12.2. Along with this, I also would like to share the serial number of switch 1. So this is where is serial number? System serial number right there. Switch 1, FCQ and something like this. And we have already discussed the model number and the iOS version. I don't need to execute same command to switch 2, but both of switch by default not running UDLD. And let me go ahead and execute the command to verify whether your UDLD is working by default or not. But I told you by default UDLD is not working. So UDLD, we can see or we can verify from every interface the UDLD are disabled. Port enabled administratively, configuration setting disabled. Port enabled operational state disabled. current bidirectional state unknown since not form any neighbor adjacency yet. So good. Go ahead, configuration mode, and enable UDLD. After UDLD, I also want to show rest of command. In global mode, you can specify the mode or working mode aggressive. If by default you are going to enable using enable command, it will work in normal mode. So right now I am going to enable only, and you can just change the message timers as well. So I have enabled on switch 1, and even then I also need to enable on particular interface. If we execute command do so UDLD, again we will find UDLD not working on any port yet. Since I told you earlier, we also need to define on particular interface. So UDLD, UDLD, then port, and after port, if we will press enter, it going to work in normal mode. If you press aggressive, if you use aggressive parameter, it will going to work with aggressive mode. So let me execute same command so that we can verify. Do so UDLD on port F0/1. Now this is enable configuration in aggressive mode, enable, and since we not form neighbor adjacency yet, the bidirectional state is unknown, and no one neighbor we can see right there, because we have configured on switch 1 only. So let me go ahead on switch number 2 and UDLD enable and particular interface, that is F0/1 UDLD port and aggressive. Now we can verify the neighbor adjacency and then rest of information. So I can execute command switch 1 or switch 2 as well. So let me execute on switch 2. Do so UDLD on port number F0/1. Oh, do so UDLD. There we go. So now we can see the current bidirectional state is bidirectional. So aggressive mode, status is aggressive, configuration is aggressive, and yes, current operation status advertisement single neighbor detected. Then what about information of that neighbor? The neighbor device name is something like the serial number, and the host name of that device pod 1 switch 1. Actually P1 switch 1 stand for pod 1 switch 1, that is right there. Similarly, we can also execute command on switch 1. We will find same thing. So far we have only enabled on particular port, that is port F0/1. You can also enable on both port if you required, but in this video I would like to keep this simple so that you can able to understand all those things. In documents you will find rest of other thing, and I highly recommend please go ahead and download these documents and go through every line. That may help you a lot. I hope the objective of this video we have already covered up. We have able after this video we able to understand the work of UDLD, configure UDLD and verify UDLD and troubleshooting UDLD. Hopefully this is informative for you. I would like to say thanks for watching.